Good morning, everybody. Welcome to video lessons. This is Sudarshan Reddy, lecturer in physics, Gaud Degree College for Women, Ramagiri, Nalgonda district. I am going to start with the second chapter of second unit of paper 1 physics. Title of the chapter is Mechanics of Rigid Bodies. So in this chapter now I am going to teach introduction and definition of rigid body, frames of references, and rotational motion of rigid body, and relationship between linear and angular quantities of motion of a rigid body. These are the concepts I am going to teach in today's class. First one is definition of rigid body, and second one frames of references, that is particularly inertial frame of reference and non-inertial frame of reference, and rotational motion of rigid body, and relation between linear and angular quantities. First, I would like to start with the introduction of rigid body mechanics. First one, already we know there is a distance between particles of a system. So they are fixed to their own positions in solids in the absence of external force. If they are also fixed even due to the application of external force, and if there is no change in magnitude and there is no change in shape of the body or shape of the system of particles, then we call it as a rigid body. So the definition on the screen is, what is rigid body is on the screen. If there is no change in distance between particles, magnitude and shape of the body, then the body is known as rigid body. Here, a body is said to be rigid if it follows the following three conditions. One is fixed internal distance between particles, and fixed magnitude and fixed shape even due to the application of external force, then we call the body as rigid body. This is what in the definition of rigid body. The study of rigid body, the study about properties of rigid body such as motion and other physical properties, etc., etc. is known as mechanics of rigid body. Particularly, it is study about properties of rigid body. We call it as mechanics of rigid bodies. Next, to define position of any body, not only rigid but also any object, to define its position, definitely we need a reference system. With the help of the reference system, we can define position. The same way, we require a fixed coordinate system to define position of a rigid body. The coordinate system, the fixed coordinate system, which is used to define or by which position of rigid body is defined, known as frame of reference. Frame of reference is nothing but a fixed coordinate system which is used to define position of an object. Now we are studying about rigid bodies, so that we define it as a fixed coordinate system which is used to define position of rigid body is known as frame of reference. So there may be more number of frame of references around an object. So with reference to a frame of reference, an object may be at rest. If we observe the same object with reference to another system, it may be in motion. That means the state of position of an object is different in different frame of references. For example, let us consider an object, the surface of a table, or a person sitting in a vehicle, four-wheeler or in a bus at rest. The person sat inside the bus on the chair at rest. So he is at rest with reference to bus. But if we observe the same person by consider earth as frame of reference, then we say that the person is moving with velocity of earth. So the first frame of reference is bus and second frame of reference is earth. According to first frame of reference, the person is at rest. According to second frame of reference, the person is in motion. So thus we say that same object may be appeared in different positions, different state of positions due to in different frames of references. That is here. So frames of references are classified into two categories. One is inertial frame of reference and other one is non-inertial frame of reference. So what is inertial frame of reference and what is non-inertial frame of reference? A frame of reference which obeys Newton's laws, particularly Newton's first law of motion, is known as inertial frame of reference. If a frame of reference which does not obey Newton's laws of motion, then we call the frame of reference as non-inertial frame of reference. So the frame of references are classified into two categories based on the obeying of Newton's laws. A frame which obey Newton's laws is inertial frame of reference. A frame which do not obey Newton's laws is called as non-inertial frame of reference. So at the bottom of the page we see the definition of frame of reference. A fixed coordinate system by which position of rigid body defined is known as frame of reference. So it is classified into two types. We discussed about it. But let us discuss now about a motion of a rigid body. A rigid body can possess three different types of motion. One is translatory motion, rotatory motion, and combination of translatory and rotatory motion. So first one, translatory motion. During the translatory motion of rigid body, all the particles of rigid body attain same displacement. Different particles of rigid body during translatory motion should not attain different distances or different displacements. So, next, second one is rotatory motion. The rigid body is fixed to a point and it rotates about a fixed axis. All the particles execute circular motion around the axis in their particular paths. Thus, all the particles move around the axis with same velocity but with different radii. This type of motion is known as rotatory motion. Rigid body can possess rotatory and translatory motion at a time. So this special type of motion of rigid body is known as rolling motion or sliding motion. So this is about three different types of motion that are possessed by a rigid body. One is translatory and second one is rotatory and third one is rolling motion. So this is motion of rigid body. Now I am going to explain about rotational motion of rigid body. We can study the motion of rigid body with the help of its center of mass, but it is not easy one, it is complicated one. So if we see the diagram, each and every particle move around the fixed axis, rotational axis, along circular path. We call this as plane rotation or two-dimensional rotation. All the particles revolve or move around the axis of rotation, the axis like this. So this type of motion of particles around the axis is known as plane rotation or two-dimensional rotation. So here if we see, let there are two particles at P1 and P2 that are moving around the fixed axis OZ and their center of rotation are A and B, and their position vectors are R1 and R2. Both the particles are moving around the axis OZ with different radii. Here the perpendicular distance between point of rotation and the point where the particle is present is defined as radius of rotation. So here for particle 1 P1, radius of rotation is AP1, and for second one BP2. Both are moving with same speed around the axis, that after a duration delta t seconds of time, both the particles made same angle delta theta. We call this delta theta as angular displacement. Angular displacement. Now, with the help of this angular displacement, we can define angular velocity, and angular velocity is represented with omega. Omega is equal to delta theta by delta t. So, a rate of change of angular displacement is defined as angular velocity. From this, you can write simple words. Omega is equal d theta by dt. So here angular velocity is virtual vector. It does not obey addition and associative property of vectors. So from this we can define angular acceleration also, that is alpha is equal to d omega by dt. So here angular acceleration alpha is defined as rate of change of angular velocity. So here it is very similar to linear velocity and linear acceleration. The rate of change of linear displacement is defined as linear velocity. The rate of change of angular displacement is known as angular velocity. Just the word linear displacement is replaced with angular displacement. The same way, by replacing linear velocity with angular velocity, we will get angular acceleration. This is about angular acceleration. Now I am going to explain about relation between linear and angular acceleration, angular quantities. So first, from laws of geometry, from the diagram, S is length of arc and angle made by this arc at a location O is theta and radius vector is r. From this we can write theta is equal to S by r. From this, S is equal to r theta. So by differentiating it with time, we will get ds by dt is equal to r d theta by dt. We know ds by dt is rate of change of linear displacement we call it as linear velocity, and d theta by dt is rate of change of angular displacement, we call it as angular velocity. So from this we can write v is equal to linear velocity, v is equal to r omega in terms of vectors. In the form of vectors, we can write it as v is equal to omega cross r, differentiate it with reference to time once again, then we will get dv by dt is equal to r d omega by dt. dv by dt is acceleration, linear acceleration, or we call it as transverse acceleration, and d omega by dt is angular acceleration, we call it as alpha. So from this, dv by dt is equal to at transversal acceleration, d omega by dt is equal to alpha angular acceleration. From this, at is equal to, you can write alpha cross r, it is in the form of vectors. Now radial acceleration ar, from centripetal force we can write it as ar is equal to v square by r. So by replacing v with r omega, we will get r square omega square by r. So from this, we will get ar is equal to r omega. So from this, the total acceleration of a rigid body in rotatory motion is written as a is equal to at plus ar. That means acceleration of a rigid body in rotation is equal to the sum of transverse acceleration and radial acceleration. So we can see the directions of radial acceleration and transverse acceleration. This indicates direction of transverse acceleration, and the acceleration along radial vector r, it is radial acceleration. So from this, the transversal acceleration is always along the tangent of particle in rotatory motion, and radial acceleration is either towards or away from the center of rotation of the particle around the axis. So this is about a rotatory motion of rigid body. So, and this is about the directions of transverse acceleration and radial acceleration. So in today's class, we discussed about definition and introduction of rigid body, inertial frame of reference, non-inertial frame of reference, and rotational motion of rigid body, and relationship between linear and angular quantities. These are the 5 concepts what we discussed in today's class. And next, relationship between torque and angular momentum. Already we discussed about this in previous chapter. Torque is defined as the vector product between position vector and force. Tau is equal to R cross F. Tau is torque and we can define angular momentum J as r cross p. R is radius vector and p is momentum vector. So you can derive relationship between these two, tau and J, and we call the relationship between these two as general equation of motion of rigid body. Let us discuss about this in next class. So this is about today's class.